So we carry on with our explanation for Chapter 3, Introduction to Railway Traction Systems, and we have reached Section 7, where we'll be talking about autonomous traction systems. And autonomous, sometimes this word is really misused. By autonomous, we need systems that are not dependent on infrastructure. So they are autonomous in their operation from the infrastructure. And basically, they can be diesel, they can be hydrogen, and they can be other kind of systems, but we'll be talking about this in detail. So without further ado, let's have a look at the section content. So this is what we'll be talking about in this section. We'll be talking about types of traction systems and introduction to autonomous traction system. We'll be talking about benefits of electric traction with infrastructure-based supply. We'll be talking about autonomous traction benefits and drawbacks. Also, we'll be talking about energy storage and fuel cell. And with this, you would be having a very, very good introduction on different types of systems. The first one is the types. Then you would understand the benefits and the drawbacks of both electrified system and the autonomous system. And we'll talk a little bit about energy storage and fuel cell. So infrastructure supply traction systems, electrified railways, you can see this kind of system. It depends on the infrastructure to get the energy to the train. So this is the electrification or the overhead lines, and the pantograph gets the electricity to the train. And we talked about traction packages, how eventually they reach to the motors and to other applications within the train itself. Then you have cable haulage, and by cable haulage, we mean that the train is dependent on being moved through cable, and you can see this in some touristic areas. Autonomous traction systems, example, the animals very long time ago, steam powered, diesel powered, which is very common these days. For example, this locomotive in the United States depends on diesel. Stored energy systems, hybrid systems. So hybrid systems use a mix of electrified systems and hybrid. Similar, very much like cars, but the most common ones are diesel, and maybe you'd have hydrogen. So what are the advantages? What are the advantages of having electric traction with infrastructure supply? So first of all, you don't have any pollution, no pollution at point of use. Second, you have high instantaneous power. You have controllability. You can control your trains. Then you have overload capability. So you can actually have an overload. You can get additional energy from the system. Also lower tail load because there is no fuel on board. There is no fuel on board, then the train weight is less. Then this will be lower impact on the infrastructure and on the maintenance. Or on the maintenance of infrastructure and on the maintenance of the rolling stock, because there is no fuel. If you have a fuel, you have to keep refueling. And low-cost energy. Low-cost energy because ease of access to that energy, but this did not include the cost of infrastructure. Now, drawbacks, the infrastructure first cost is very high, infrastructure maintenance cost, and we do not mean the track by that. We mean the overhead lines, because you would have less damage to the track, but you need to maintain that electrification infrastructure. Infrastructure reliability, also you need to make sure this infrastructure, this electrification infrastructure is reliable and the trains can always depend on that. One of the aspects is that you can be dependent on a sole power supplier. So this should be sole power supplier, and we means maybe you have that you are getting your electricity from a certain company, and if this company decided to shut the electricity on your system, then your trains will not be running. And this is in a very, very severe cases. Then you have transmission losses, and by transmission losses, moving electricity through those overhead wires will lead to transmission losses. And also you might have potential for electromagnetic interference, EMC, or what is known as EMC. So your telecommunication equipment and your telecommunication infrastructure might get affected. Now, autonomous traction systems, what are the benefits and what are the drawbacks? So you have simplified and cheaper infrastructure. There is no, those lines are not there, overhead lines are not there. Little transmission losses, very low losses in terms of transmission because there is no wires. Flexibility and ease of interoperability, and by that we means, for example, if you want to move your trains to another route, you can do that easily because it's not dependent on the infrastructure. What is dependent on is a gauge, and if the gauge is fine, then your train will be running on that infrastructure. Potential for equal efficiency. There is a great, it can be very efficient, but in general, the electrified system is more efficient. Easier limitation of electromagnetic interference. Maybe there is not much electromagnetic interference because there is not much electrified systems or electrified infrastructure, and possibility of stored energy, and you can store energy. What are the drawbacks? Onboard source of energy, and this can be a risk hazard. Maybe, for example, it can be if you had an accident, it might result on a serious damage if fire reach the fuel storage. So it can be the problem you have. Your source of energy is on board. The second one is refueling points required, and by that we means that you always need to refuel your trains, and this would take time, and sometimes you have to take your trains out of service or disrupt the timetable. Reduced or non-existence regeneration capability. So you can't benefit from the gradients that is there by regenerating energy as you can do in the electrified system. This is why that system is more efficient. And infrastructure maintenance cost. And by that we means because you are running heavier trains, this will lead to higher damage on infrastructure, and sometimes can cause more CO2 emissions. So, and by saying causing more CO2 emissions, we means that it might result in higher levels of pollution. So very common feature of diesel, but also you can add those filters and you can add this process to make it as environmentally friendly as possible. Now we'll talk about energy storage and fuel cell. How you can energy storage? You can do it in a chemical as we do it most of the time. Gas, petrol, diesel, ethanol, coal, biomass, all kinds of material or material that you can store energy, then you can burn it. Flywheel and battery is another form of storing energy. Many sources to store energy are being used. Each has its own requirements, limitations, and outputs. So the one that is now, there is some trains that have used hydrogen, and those trains, for example, Alstom, I think, developed a hydrogen train, and before that was used in Germany and maybe used in the United Kingdom and a little bit in France. So what is the process? Happens, oxygen passes at high temperature and become oxygen ions. Inside fuel cells is mixed with natural gas, methane, and carbon dioxide is produced. Ideal fuel is hydrogen, and hot water generated keeps the system at the necessary high operating temperature. So this is how hydrogen works, and hydrogen trains work. Battery storage efficiency. Lithium, there are different types of batteries. The most efficient one is lithium polymer, which can store up to 0.56 million joule per kilogram. However, it's still very low, and you can't. This energy storage is a topic that will gain more attention in the future. Lead, a very old type of material that is being used inside batteries, 0.01 million joules per kilogram. The conclusion: electric power is not the be-all and end-all in rail. So it's not about all of our infrastructure should be electrified or not. There are sometimes autonomous power that can be useful. These times, when you have low traffic intensity routes, you don't have to build that much infrastructure if you don't have much traffic. So autonomous trains will be working fine. Routes with seasonal traffic, if you have seasonal traffic like you are a tourism destination or so on, maybe you'd consider that. And autonomous power can be environmentally friendly if it was well utilized. This is some of the lessons that we have learned. I hope this lesson have given you a good introduction about autonomous traction systems. We'll see you in the next section, and we'll be talking about new topic and in the introduction to traction systems chapter. Have a great evening.